All right, this is Chapter 7, Lesson 6. It's on cross-sections of three-dimensional figures. One thing I've mentioned to you as we get into geometry is very detailed on its vocabulary, so you need to be really careful and make sure you study vocabulary. So I'm going to be covering a number of vocabulary terms and shapes and things like that today, then we'll go into cross-sections. So first of all, a plane. A plane is a flat surface that goes forever in all directions. In fact, we talk a lot of times about plane geometry, which just means flat geometry. It means it doesn't have that third dimension in it. So a plane goes forever in all directions, a flat surface. Parallel. Parallel is a word you need to know. I always think about the L's in the word parallel are what you consider parallel. Parallel means they're always going to be the same distance apart. They would never intersect. Even if you continued them on forever, they would just always be the same distance apart, never intersecting. So, by the way, the symbol for parallel is just what looks like two little L's by each other. All right, perpendicular. Perpendicular means they intersect to form right angles. And the symbol for perpendicular is an upside down T because it forms right angles. And a lot of times they won't put that little square in the symbol, but that's how they'll, like if this was a right triangle, they would put a little right sign right there to let you know it's a right triangle. Okay, it's perpendicular, forms right angles. Let me go through a couple of these shapes and then I'll use them to talk about edges, faces, bases, and vertexes. Okay? Vertices, I guess is the way you're supposed to say that. So a prism. A prism is defined as a three-dimensional figure, three-dimensional solid, sometimes they call them, that has two congruent parallel bases. So when I look at this, a lot of times people get confused and think that the base is what it's sitting on. Remember, if I change my paper, it would look like it was sitting on something different. And really, we're not based in a gravity world when we're just dealing with geometry. So it's not what it's sitting on. The base has a very defined definition. I mean, it's very specific. So when I look at this, the bases are the congruent parallel sides when you're dealing with a prism. So the only ones that are congruent and parallel is this triangle right up here, triangle ABC, and triangle DEF. They are congruent and they are parallel. And so those are what we call the bases. Okay? The edges. Edges are where two planes meet. So the line segment AD is where this plane right here and this plane back on the back, plane ADBE and plane DFCA, meet at that line, which we would call an edge. AD is an edge, AB is a different edge, DE is a different edge, BC is a different edge, CF is a different edge. I'm going to dot this one just so you see it, but EF, that you can't see because it's on the back there, and BE, those are all of the edges. The faces are the flat sides, not just the bases. Base is a special one, but faces are the flat sides. For example, triangle ABC, triangle DEF, those were the two that were your bases as well as faces, but you also have this rectangle DACF. You have a rectangle on the back, ADEB, and you have a rectangle on the bottom, BCFE. So those are what we consider the faces. The vertexes, the vertices, excuse me, I keep saying that incorrectly. The vertices are where three planes meet, and they are what we consider the points, right? All of these points where three vertices meet. So let me just talk about one or two of these. A is where the plane back here, ABED, that rectangle, meets BCE, the triangle, and it also meets DFCA, this face up here. So that's where three of them meet, and that's what we call a vertex. All right, so I'll talk about a pyramid. Pyramid has a different definition. It doesn't have two bases. It has one base. The base that all of the vertices from that base go up to a single other vertex, which we a lot of times call an apex, the highest point from the base. So here we have a base of A, B, C, D, that rectangle at least, maybe a square according to what we know about it, on the bottom, and we have a vertex E, which I would consider the apex, the highest point from that. So it has one base, and then it has a whole bunch of triangles for sides. That's what a pyramid will always consist of. Now, it won't necessarily have a rectangle or square on the bottom. It could be a triangle on the bottom. You can have a triangular pyramid. You could have an octagon on the bottom. You'd have an octagonal pyramid. Remember, a pyramid is named by its base. So this time, if that's a rectangle, I would call it a rectangular pyramid. A prism is also named by its base. This is a triangle for the base, so it would be a triangular prism. Now, you could have different kinds of prisms. Now the congruent parallel sides are a rectangle, so that would be a rectangular prism. All right. Go down for a couple more. Cylinder and cone. Cylinder, obviously the bases. This doesn't fit with the same definition of these because these are polyhedrons, which means they're made out of two-dimensional figures, which are polygons, which means they have at least 3 sides and things like that. No curves. Well, here we have curves on both of these, so these don't fit that definition. But a cylinder, of course, has 2 bases that are congruent and parallel. A circle and a circle. That's the definition of a cylinder. Those are your bases. It's very similar to a prism in the fact that it has 2 congruent parallel bases, but it has curves, so it doesn't fit that same definition exactly. That's a cylinder. There would be your bases. That's your face, and then of course this has a curve, so you can't really call it just a face or a two-dimensional shape, I guess. All right, cone. Cone has a base that is a circle, and then much like the pyramid, comes to an apex or one vertex. So a cone has one vertex and a circle for a base. All right, knowing those shapes a little bit, especially with the words plane, parallel, perpendicular, and then of course all the pieces, we're going to do the guided practice off page. Got to find what page that is. It is page 596. First one says, identify the figure. So let's talk about what this figure is. I look at it and I see a congruent parallel triangle on the top and the bottom. So if it has a congruent parallel base, remember what that was called? It's called a prism, and we name it by its congruent parallel base. This is what we call a triangular prism. All right. It says, then name the bases, faces, edges, and vertices. Well, the bases are going to be faces, so I'm going to go ahead and denote them with a B on top of them just so you see them. The bases in this case would be the triangles. So triangle QRS is a base, and also triangle, the bottom one, TVU, is a base. Now there are other faces. There's a rectangle right over here, which we can call it rectangle QTVS. You have one over here, which is RUVS. And you have one on the back, which is QRUT. Notice you have 1, 2, 3, 4, 5 sides. 1, 2, 3, 4, 5. These ones are special because they are the bases, the congruent parallel sides. It also asks you to name the edges. The edges are, remember, the lines where 2 planes meet. So QR is where this top triangle and this back rectangle meet. So call that QR, line segment QR. I have line segment QS, line segment RS. I also have line segment RU. I have line segment SV. I have line segment QT. By the way, there's QT, just so you can see it. There was SV, there's RU. Okay, I've taken care of all of the top, QR, RS, and QS. Let me go ahead and take care of the bottom. I have TV, I have VU, and I have UT. And those are my edges. It also asks for the, what else? Vertices. Well, the vertices are the points. So Q, R, U, V, S, and T. Those are the vertices. And skew lines is another thing that it asks for. A skew line means they're not in the same plane. So for example, if I go back to QR, it's going to not ever intersect, even if you continue them forever, with SV because they're not in the same plane. QR is on a plane back here. SV is in a plane going up right here. Those are what we call skew lines. What else to say? Then I did, okay, that's the last one for that one. All right, number 2. Last thing it says is describe the shape resulting from the cross section shown. Well, first of all, let's talk about what shape this is. It's a pyramid. It comes to an apex from a base. The base is a triangle, so this is called a triangular pyramid. Triangular pyramid, and a cross section is if you were to take a plane and just chop this thing with a plane. And if, let me change colors here. if I chop this thing with a plane and it went through the vertex right here, and kind of like a plane that goes forever right through there, if you can look at what that would cut, it would cut a triangle when you chop that thing in half. And if you opened it up and looked at it flat, you'd end up looking at a triangle. Okay? There are other ways you could cut that, right? What if you cut it off center? Instead of through the apex, you cut it over here and you went straight down. Well, then you would be looking at something that slopes this way and slopes this way, and you'd be looking at a trapezoid, because it wouldn't go all the way to the apex. You'd be looking at just a trapezoid. So when we talk about a cross section, let's just go up here and do a couple more cross sections so you see them. Okay, now this is where you have to understand those words parallel and perpendicular. If I said cutting a cylinder parallel to its base, well, remember the bases are the circles, so that means I'm cutting it across here. If I cut it across here and opened it up, you'd be looking at a circle. If I said cut it perpendicular to its base, now you're cutting it this way. If you opened it up, you wouldn't be able to see a curve if you looked at it flat. You'd just be looking at a rectangle. Let's do a cone. If I said parallel to its base, well, that'd be like this. You'd open it up and you'd be looking at a circle. If I said perpendicular to its base through the apex, you'd be cutting it like this. You'd be looking at a triangle. Go up to this one, prism. If I said parallel to its base, well, if you cut it parallel to its base and opened it up, you'd be looking at that triangle. If I said perpendicular to its base, now think about what that is. Perpendicular to its base would be cutting it like this, right? And you'd end up with a rectangle. Pyramid. Now this is more like a rectangular pyramid, right? So if I said perpendicular to its base at a right angle through the apex, well, you'd be looking at a triangle. If I said, by the way, that would look like this. If I said perpendicular to its base but not through its apex, you're going to hit there, and you'll end up with a trapezoid. And if I said parallel to its base, you'd end up with the shape of its base, only smaller, so it would just be a rectangle, and you'd have several different cross sections. Remember, the cross section is chopping it and opening it up to look at it, how a plane intersects with a three-dimensional figure.